Alright, so today we move on from our inverse functions, and now we're starting to take a look at solving trig equations. So the whole purpose of even learning inverse functions is so that we can solve trig functions, meaning we're solving an equation with a trig function so that we can find a solution for the angle measure theta. So here's a basic one. Sine of theta equals negative root 3 over 2. So the first thing you're going to do, and I realize this is simplistic and you guys probably know this already, but the first thing we want to do is we're going to take the sine inverse on both sides, because what happens here, sine inverse and the sine function cancel, because we always said sine inverse functions are finding us angle measures. So our angle measure is going to equal the sine inverse negative root 3 over 2. So we said, let's see, if we take the inverse function of a negative, or an sine inverse of a negative, we're going to have an answer in quadrant 4. So we have that right there, okay? Negative root 3, 2, 1. We know that this reference angle is 60 degrees. The reference angle is the part that we want the most, because what it's telling us is it's giving us what we need to, or it's giving us the information needed to find here. There's one thing that's different with inverse functions only had one solution, and it was limited. Since we're solving an equation, we want theta, where theta is between 0 and 360, so we know one of our solutions to be here, reference angle is 60. We also know that one of our solutions will be here, it also has a reference angle of 60. So we are trying to solve for the two angle measures I drew in green, which, if we look at them, you should know with 240 and 300. Nice. The hard part is, you know, inverse functions are severely limited in anything, and so it's hard to kind of transfer from that to now just equations. Alright, now it's the same thing again, but pay attention to the interval is in radians. Our answer should be in radians. So we're given this. Alright, so then we know that our reference angle is going to equal the cosine of negative 1/2, or the cosine inverse, negative 1/2. So if we're looking at a picture, cosine inverse is negative there, and it's negative 1 over 2, which means this other side will be a root 3, which gives us a reference angle of 60 again. So we also know cosine is negative down here in quadrant 3. So the answers we're looking for, I'm highlighting in blue. So your answers here would be, well, this is 180, right? That's 180. 60 degrees pass in both directions. You would have a 120 and a 240. But we want, once again, we want our answers in radians. So our answers should be 2 pi over 3 and 4 pi over 3. Now, I think it's easier to work it out in radians than skipping this step, but if you're not comfortable with radians, you have to use that step, then use the step. The most important part is that we're getting it correct. Alright, so try solving this guy on your own, and actually I will do this one together. So what I want to try to do is I want to solve this cosine of t as if it was an x. Meaning, how would you solve 8x plus 13 equals 21? Hopefully, we remember the basic steps. So we get 8x will equal 8, so x equals 1. Now our x, that's actually a cosine of t. So the cosine of t equals 1, that means that t equals cosine inverse of 1. Cosine equals 1 at 0 degrees. And that's it. The only place it equals 1. And those are the quadrantal angles if you're looking at the unit circle. Because remember, that's the coordinate right there because it's 1, 0. Alright, try solving this equation on your own. And pause the video real quick, and then I'll show my work. And that way you can see if you're on the right track. Alright, so when all worked out, you should have sine equal to negative root 3 over 2. So if you pause again, you can check your work, and then hit resume. So from here, now we're doing our sine inverse thing again. So theta equals the sine inverse, negative root 3 over 2. So then let's figure it out here. So sine is negative there. That's a root 3. That's a 2. That's a negative root 3. That's a 1. So our reference angle is 60 degrees, which means our other answer is going to be sine's also negative there with a reference angle of 60. So we're trying to find angle measure from there to there and from here to here that I've highlighted in purple. Now our interval is in radians. So 60 is also the same as pi over 3. So we're going to have answers. This one here is going to be 5 pi over 3. And this one here is going to be, well, see, that's 1 pi, 1 past that, so it's going to be 4 pi over 3. So those are your two solutions. Alright, so lastly we have the tangent, and the reason why I wanted to show you this is when you solve it, it's hard if you think about it to find an exact value triangle like that. However, if we unrationalize it, that fits some of the triangles we worked with. So if we're drawing it out, tangent inverse is negative here. So we have a negative 1 root 3. That should be a 2, so that's 30 degrees, which means our second, let's see, tangent is also negative 2, so that's 30 degrees, which 30 degrees is also pi over 6. And so this is pi over 6, this is pi. So we're 1 pi over 6 behind that, so that puts us at 5 pi over 6. I love fractions. So this would be 2 pi, which is also 12 pi over 6. And this is 1 before it, so that would then have to be 11 pi over 6. So there's our answers. Hopefully that makes sense. I have a worksheet for this. If you have any questions, let me know. Take it easy. See you tomorrow.